Perkins 4000 series engines. I mentioned session 1 because we have another session. It's going to be session 2. In this session, we will be getting acquainted with the engine and talk about the updates that we have or Perkins have done on this engine. On session 2, which is going to be later, 2 or 3 months from now, we will set up a date. We will be talking about how to adjust the injectors and the valves on these engines, the calibration and timing of injectors. This is going to be in session 2. So in session 1, we will get acquainted with the engine itself, plus talking about the updates, what Perkins have done on these engines as upgradings. Let's start this session. Okay, so these are the 4000 series engines. They come in different sizes. These engines were, designed by a British company called Dorman. Long time ago, Perkins took over this company, and they adopted this engine, and they started making, improvements on this engine, and they called it Perkins 4000 series. This is the facility of Perkins where they manufacture and assemble these engines. It is in a small city in UK called Stafford. This is the facility. Concerning the models that we have, on these, 4000 series engines, we have many sizes. We have 4006, which means 6-cylinder engines. We have 4008, 4012, 4016. These are the sizes we have. And many improvements have been done on these engines. Every once in a while, they make improvements on these engines. We will talk about these improvements whenever we go, further with this lecture. By the way, if you look at the 4016, at the moment, we have two models. We have the 4016, the standard, and we have the upgraded type, which is called TRG. The TRG type, we have 3 sizes, TRG1, 2, and 3. The TRG1 covers the 1800 kVA genset size. The TRG2 covers the 2000 kVA size, and the TRG3 covers the 2250 kVA size. This is the biggest size Perkins offers. These engines run on 50 hertz only. If somebody needs a 60 hertz version, a special order has to be, coordinated with Perkins to send you a 60 hertz type engine. Talking about the 4006, I'm talking about the ones, 𝐂𝐨 deal with, because they have like 4006 TWG. We don't deal with this type or this model. This is what we deal with, the 4006 THG. As 𝐂𝐨, we buy these engines that cover the 750 kVA size and the 800 kVA size as well. Looking at this side of the engine, we have 3 oil filters, 1 fuel filter. The water pump is gear driven, and these engines have electronic governors. They are controlled by an electronic governor. We will talk about this when we go further. This is the controller. It is made by a German company called 𝐂𝐨𝐧𝐭𝐚𝐜. These engines have separate heads. All the 4000 series, they have separate heads. They don't have one common big head. No, we have separate heads. So if this is a 6-cylinder engine, it means we have 6 heads mounted on this engine. Looking at the other side of the engine, this is the other side. You can see clearly that we have 6 heads. And down below here, we have windows, side windows, to make it easier for us. For example, if you want to take out one of these pistons, let's say piston number 5, this one, You don't have to take all the heads. Just head number 5, open the window in here, the side window, to dismantle the mounting bolts of the connecting rod and take out the piston all the way up. This makes our lives easier. This is the 4008, almost the same thing, but it has 2 extra heads. It's the same head that we have on the 4006. Exactly the same, copy paste. Oil filters, we have 3 as well. The same filters we have on the 4006, and 1 fuel filter. Okay, this is the other side of the 4008. Again, we see the windows. By the way, the DC alternator, it is belt driven, and the driver is the water pump. The water pump from the other end has a shaft where we have a pulley, and it will be driving the DC alternator. Usually on engines, it is the crankshaft pulley that will be driving the DC alternator. On these engines, no, it's not this way. It's different. The 4012. Here we go. This is 4012. It's a V engine. By the way, on the 4000 series, the 4006 and the 8 are inline engines, straight engines. The 12 and the 16 are of the V type. Okay, here we mentioned A. What do we mean by A? Bank A. Looking from the front side of the engine from here to your left, this is bank A. So the numbering of the pistons would be like this. This is A1, A2, A3, and so forth. And the compressed air is water cooled. That's why we have the W. W means water cooled. It's not air cooled. We don't have an air cooler on these engines. We have this heat exchanger where water comes in and out. And this is the air coming through the air filter, getting compressed by the turbocharger, getting very hot, get in here, get relatively cooled down using the engine water, and then it will go to the combustion chambers. Again, we have the same oil filters on this side of the engine that we have on the inline engines, and the same fuel filter, 1 fuel filter only. Looking at the other side, bank B. This is bank B. Again, from the front side of the engine, looking from the front side of the engine, this side we call it bank A, this side we call it bank B. Again, numbering the pistons, this is B1, B2, B3, B4, and B5, B6. It is a must to know how we number the pistons, because we will be needing this whenever we talk in session 2 about how to adjust the valves and the injectors. We must know this. Again, we have another cooler for the compressed air on this side as well. And we have another 3 oil filters. So the total number of oil filters would be 6. It is the same oil filter we use on the 4006 and the 4008, but the number here is double. We have 6. 1 fuel filter, 6 oil filters. If you look in here, you can see that this oil filter is a little bit away from its friends. Why? Because this oil filter is used to filter the oil that is sprayed by the piston cooling jets. That's why. On the inline engines, we do not filter the oil that will go to the piston cooling jets, but on this one, yes, we do. So this filter is a little bit apart from its friends. Same thing from the other side. So this one will be used plus the other one on the other side to filter the oil that is going through the piston cooling jets. Same engine, but it's air-to-air cooling system. We don't have a W here. We have an A, which means we have an air cooler, another radiator besides the coolant radiator to cool down the compressed air. That's how the air will be going in. Air filter, air will get in, get compressed by the turbocharger, getting very hot, go all the way here to the air cooler, get cooled down, and then come back again and get to all the combustion chambers. Again, 3 oil filters. This is bank A, looking from the front side of the engine. This is A, A1, A2, A3, and so forth. And the same fuel filter, one fuel filter, which we use on the previously mentioned engines. Okay, the other side, bank B, again, from this side, this is B, B1, B2, B3, and so forth. 3 oil filters. Sorry, B1, B2, B3, B4, B5, and B6. This is the front side of the engine, okay? And 3 oil filters as well. So the total number of oil filters would be 6, 1 fuel filter. The big engine, the 4016. Again, we have 8 pistons on this side or 8 heads on this side, likewise on the other side. Okay, so this is bank A looking from this side. So this is A1, A2, A3, and so forth. We have on this engine 4 filters, not 3. The last 3, this one, and this one, are oil filters. The one facing the front side of the engine is the fuel filter. It's not anymore the filter that we have on the previously mentioned engines. On this engine, it's different. The other side of the engine. This is bank B from the front side here. B1, B2, B3, B4, whatever. Again, here we have 4 filters as well. Number 2, 3, and 4 are the oil filters. Number 1, the one facing the front side of the engine, is the fuel filter. So it's a bit different compared to the other engines that we have mentioned previously. This is the TRG type. It's a bit different. The turbochargers are different. Air filters are different. These are the fuel filters. These are the oil filters. It's they have made many modifications. This is the Heinzman controller on the engine. Talking about some mechanical features of this engine. Connecting rods on the inline engines, the 4006 and the 4008, both sides of the connecting rod are chamfered. This is the one for the V engines, the 4012 and the 4016. From this side, it is like a mirror face. From the other side is chamfered. We must know this. Whenever you want to replace one of the connecting rods, you must read what is written on the connecting rod. Its weight. I'm talking about the weight. It is written in magic ink on the connecting rod. Okay, so you must read the weight and get a replacement connecting rod with the same weight. The acceptable difference in weights is up to 2 ounces. Here you can read here 20 pounds, for example, and 3 ounces. Okay, so you must get a replacement connecting rod with the same weight or a maximum difference of 2 ounces. Okay, again, it is mentioned in magic ink. I think the color is yellow, as I remember. These are the pistons we have on the engines. Of course, the ones we have on the inline engines are the same, but the ones on the V engines are not the same like the ones on the inline engines. Just like any other Perkins engines, we have 3 piston rings. The one at the bottom is the oil ring. The ones at the top, the two at the top, are the pressure rings. This is the piston cooling jet, which is made from plastic, a composite material. This is what we have on the inline engines. This is the one we have on the V engines. It is made from aluminum. This is the piston cooling jet. The cylinder heads. We mentioned previously that cylinder heads are the same among the whole range, but there are some differences, minor differences between the heads on the V engines compared to the heads on the inline engines. That's how the heads look like. We have two inlet valves, two exhaust valves. The difference between the head on the V engine compared to the head on the inline engine is that on the V engines, the head has this oil drain, little tiny opening through which oil on this here, whenever oil accumulates here, the lubrication oil, it will be redirected through this opening, and the opening matching this on the engine head to go engine block to go back to the oil sump. We don't have this opening on the heads on the inline engines. Can I use this head, the V cylinder head, on the inline engines? Yes. Can I use the head on the inline engines on the V engines? No, because we don't have this opening. We cannot use it. These are the rocker boxes. Just a glimpse. Here we should have the injectors. We talk about the injectors in a minute. Keep in mind this, link, this little tiny link, which is around 8 centimeters long. Special tools that we need in general for the engine. Of course, there are many special tools to be used. I'm gonna mention the important ones that we must, have. This is the turning tool with which we turn the engine whenever we want to adjust the valves and the injectors. It is a must to have such tool. This is the liner extractor, cylinder liner extractor. We must have this, to replace liners. And we must have something like this to compress the piston rings with. Whenever you mount the piston inside the new liners, it is a must to have something like this. You can purchase something equivalent in your local markets or buy this from Perkins. This is a piston lifter. You must have this one in order to take out any piston that you need to replace, or replace its rings, or replace the whole piston. DTI gauge. It is an added value to have, such special tool. Depends which method you use when you adjust the injectors. Myself, I don't use this one. We will talk about this in session 2. We will be talking in session 2 about how to adjust the injectors using the short way method, because we have 2 methods to adjust injectors. We have the standard method, where you turn your engine 4 times to finish the job, or the short way method, turning the engine only twice to adjust the injectors and the valves as well. So using a DTI gauge is an added value in short way method. Myself, I don't use it. We'll talk about this in session 2. We need this special tool to adjust the injector in the calibration, zero calibration step. We'll talk about this in session 2. We need these compressing bars as well to compress the injectors with. Okay, we must have, these compressing bars as well. It is a must. This clamp, we use it whenever we test the injectors to see how much is the fuel pressure and how they are spraying fuel. whether they are okay or not okay. We must have, this special tool. You need two of these because the injectors, the plunger inside the injector, it might be a 12 millimeter in diameter or it might be 14 millimeter. So we need two of these. We have two types of injectors on the 4000 series, 12 millimeters plunger and 14 millimeters plunger. Done with the special tools. Back again to the engine. The oil pumps on the inline or the V engines, they are mounted externally. Usually oil pumps are mounted inside the oil sump. This is not the case, with these engines. It is mounted externally. At the tip of the oil pump, we have the fuel lift pump, which is driven by the shaft of the oil pump. It's not the same for the V engines and the inline engines. The oil pump and the fuel lift pump are not the same. They look the same, but they are not. How does the fuel and the oil, lubricating oil, get to the heads? We have common rails. If it's a V-type engine, we have two rails like this one on each bank, A and B. If it's an inline engine, we'll be having one rail. So this is the rail for the fuel supply, through which fuel get to the injectors through the head through these pipes. So if this is a 6-cylinder engine, we have 6 of these pipes for each head. And this is the fuel return rail. This is the pipe, which is connected to the head, through which fuel returns back to the fuel rail. And the one at the bottom is the oil feed gallery or oil feed rail, through which oil get through a pipe as well. You can barely see it. Here we go. To get to the head, to lubricate the moving parts inside the head. Here on the fuel return rail, we have a check valve. The check valve here is to maintain around 65 psi fuel pressure. That's why we have fuel check valve. And looking at the injectors now mounted, and you can see the horizontal link connected to the injectors. We'll talk about this, in a minute. This is the breathing system. On the V engines, we have two of these. Okay, here we go. This is the crankcase pressure getting through this pipe. And here we have a filter inside. And from here, we'll be having an external hose going out through which fumes go out. Inside the breathing apartment, the breathing hose, housing, we have this strainer. It must be cleaned every 250 hours. Taken out, rinse in diesel or whatever, clean it and put it back. Looking at the fuel system of the inline engines, the starting point, this is the fuel filter, this is the fuel lift pump, fuel be going in all the way up to the rails to supply fuel to the injectors going through the heads. For the V engines, again, one fuel filter for the 4012. Fuel will get filtered, go through to the fuel lift pump, and all the way up to this bank, bank A, and to the other side to bank B, where we have two fuel rails. Another view, side view of the heads, how the fuel is getting in and out from the head to supply fuel to the injectors. Plus, the oil is not mentioned here, but there should be another pipe, showing how the oil is going in. Again, an exploded view of the injector and the horizontal link. This is an exploded view of the adjustable link, which is around 8 centimeters in long. Here we go. This is the common bar through which, these vertical links and the horizontal links will be moving the arm of the injectors. We'll talk about the injectors in a minute to explain what we mean by this. Do you see this arm? These are the injectors. How is the fuel compressed? We are using a mechanical force, a rocker arm, compressing this plunger. We mentioned before that the plunger here might be 12 millimeters or 14 millimeters. Okay, two types of injectors. So the force used to compress the fuel inside the injectors is a mechanical force, which is a rocker arm. And this arm, which moves this way or the other way, if it moves this way, more fuel will be sprayed. If it moves the other way, less fuel will be sprayed. This arm is connected to the actuator of the electronic governor through links. By the way, the fuel pressure for brand new injectors should be around 250 bars. There you go. Another view of the injector itself. This is the control arm, which is connected to the actuator through links. The timing pin, we'll not talk about this in this session. This will be talking about in session 2 when we talk about calibration and timing. The rocker arms, we have 3 rocker arms at the top of each piston. This one, if this is the front side of the engine, this is the one for the inlet valves. The rear one, you can barely see it. It is for the exhaust valves, and the big one in the middle is the one used to compress the plunger and the fuel inside the injector. For all engines where fuel is going inside the heads, like MIWI engines, the 2000 series, many of these, big engines where fuel go inside the heads, the fuel will be collecting heat from the heads because the temperatures of the heads is around 200 degrees Celsius. So fuel will be picking up heat from the heads. We must cool down the fuel before it goes back to the fuel tank. That's why on most of the medium size and the big engine sizes, we have fuel coolers where the fuel, returning fuel, will be going through a fuel cooler to get fuel, to get cooled down before going back to the fuel tank. Why? Because according to Perkins, if the temperatures of the fuel exceeds 58 degrees Celsius, 55 for Caterpillar, the fuel burning efficiency will go down. That's why we must keep the fuel temperatures below 58 or 55 degrees Celsius. Okay, talking about the electronic governor now. So this is the Heisman controller. Long time ago, it was of the analog type. It has potentiometers inside with which you can make adjustments. At the moment, it is of the digital type. So this is the controller. And this is the actuator. This is the actuator to which the links are connected that will be moving the arms of the injectors to spray less or more fuel. Who is giving orders to the actuator to move this way or the other way? It is the controller. It's called Panderos as well. Okay, 5 wires will go from the controller to the actuator. 2 will be a variable voltage power supply to the actuator to make its arm move this way or the other way. Okay, plus another 3 wires connected to a position sensor inside the actuator that will help the Panderos, the controller, to know by how many degrees the arm of the actuator has moved. To make things clearer, how the actuator is connected to the arms of the injectors. This is the injector, this is the rocker arm, which is pressing down the plungers, which is moved by the lobes, by a lobe on the camshaft side. This is the actuator. This is the shaft of the actuator. This is a link making this common rod, which is all the way to the other end of the engine, move clockwise or counterclockwise. To this rod, we have this vertical link connected to it to be moved upward or downward. And this vertical link will be connected to this 8 centimeter, adjustable link that is connected to the arm of the injector to make it move this way or the other way to spray more fuel or less fuel. Another view, this is the actuator again, the link, this is the common rod, this is the vertical link, this is the horizontal link, which is connected to the arm of the injector. This is the rocker arm, which is pressing the plunger of the injector through a push rod, which is touching the lobes on the camshaft side. Another view from a different angle. The actuator, the link, the common rod. This is the vertical link connected to the horizontal link to the arm of the injector. This is the push rod. This is the rocker arm, which is pushing the plunger of the injector down to spray fuel. So this arm is controlling the amount of fuel to be sprayed. This rocker arm is highly compressing the fuel inside the injector. Electrical connections. This is the controller again. What is connected to the controller? We have two sensors connected to these Heisman controllers, the digital type, of course. We have a speed sensor connected to the controller so that the controller would know how much is the speed of the engine. For example, when load is applied, the speed of the engine would drop. The Heisman controller will know that the speed has dropped based on the readings it is receiving from the magnetic pickup, the speed sensor. So it will give orders to the actuator to move its arm this way or the other way to spray more fuel so that the speed will go up again to 1500 RPM. Another sensor is connected to these controllers. It is a boost pressure sensor. This sensor is measuring the pressure of the air, compressed air. Based on this information, the controller knows how much oxygen is getting inside the engine. Because, at high elevations, we'll be having less oxygen. So the engine will derate, give less power based on the readings the controller is getting from this boost pressure sensor. Okay, talking about the updates. What have Perkins done on these engines? A twin bank governing. Here we are talking about the V engines. Usually on the previous types, we have one actuator and two links going to each bank, bank A and bank B, to make both move. At the moment, they have introduced V engines with two actuators. Each actuator is connected to a bank, one for bank A, one for bank B. Why? Because whenever a low load is applied on the engine, if both banks are working, it means that we have low load applied on the engine and the engine will start to consume oil. Whenever you have low loads applied on any engine in general, the engine piston rings will not open up properly and they will not work as a perfect seal and you will be having oil consumption. So whenever the load is below 25%, one bank will be working, bank A, for example, okay? Bank B will be off. Whenever the load exceeds 25%, both banks will start, working. That's how it works. We have seen this on many other big engines like MTU engines, the German engines. Besides, another thing that they have done on these engines, now instead of having a Heisman controller, what we are seeing is an ECM. It is of the ADAM 5 type. ADAM stands for Advanced Diesel Electronic Management. So it is ADAM 5 type. It is replacing the Panderos, the Heisman controller. I will talk about this when I go down further, the ME with style electronic injectors. Here we go. On the V engines, this is what we used to have, one actuator and two links, going to each bank. Now what we have, two actuators, not one, like here, two actuators. Each one is for a separate bank. This is for bank A, this is for bank B. So that whenever the load is below 25%, this will be off. It will not be opening up the injectors to spray fuel. This will be on, only bank A will be working instead of bank B. Whenever load exceeds 25%, both will be working. This is the engine we call PEC. That's what we call these, newly introduced engines having an ECM. Okay, this is the ECM, the Adam 5. This is the location of the ECM on the engine. Starting this year, Q4, Perkins have upgraded this 4000 series engines. Now they called it 5000 series. We'll be still having the 4000 series besides the 5000 series. It's an 5000 is an option. 5000, it is an upgraded 4000 series engines, but it is fully electronic engine. We call it MIUI. Okay, the injectors will not be the same. They will be having a solenoid at their top, controlled by the ECM. I don't know if it's going to be an ECM Adam 5 or Adam 6 type, the up-to-date type, but it's going to be an electronic engine. MIUI type, that's what we call it. Mechanically actuated, electronically controlled unit injection. Q4 this year, the 5006 and the 5008 will be introduced. Okay, they are available now. Okay, but at the moment, they will be running as 50 hertz only. Okay, by the end of 2023, Q4 2023, 5012 and 5016 will be introduced. Okay, fully electronic engines. They will be running as 50 hertz only. By the end of 2024, these engines, all of them, will be introduced as switchable engines, 50, 60 hertz type of engines by the end of 2024. Talking about some benefits of this engine, the oil consumption is I think it's going to be like 0.15, which means for every 100 liters of fuel consumed, the engine maximum allowable oil consumption will be 0.15 liters, compared to the 4000 series that we have at the moment, which is like it is more than 0.25 percent. So this is 0.15%, which is good. I'm talking about the 5000 series, of course. Okay, the oil consumption will be less, 0.15 liters of oil maximum for every 100 liters of fuel consumed. The 4000 series, I'll talk about optimistic numbers, 0.25. It might be more than that. It might go to 0.5%. So 0.25%, it means 0.25 liters of oil, maximum oil consumption for every 100 liters of fuel consumed. Okay, plus this, newly introduced engines, the 5000 series, will be having, more options, more sensors, like water in fuel sensors. If there's any water in the fuel, it will be detected. Usually these sensors are mounted in the filters, or the fuel filters head. Okay, and the ECM will give you a warning that there's water in the fuel. Okay, plus many other good upgradings. Hopefully we'll be seeing these engines soon. Basically, this is it for today. This is just an overview up to let you know about the updates of these engines, what they have done so far, and get acquainted with the engine. And in session 2, hopefully, we'll be talking about how to make the calibration and timing for the injectors of these engines, the 4000 series. Questions? Hi, why using only one fuel filter in this series, considering the amount of fuel delivered? These filters that we have on these engines, it's a big filter, it's not a small one, which is enough to withstand 500 running hours. Usually, we are not changing oil in our countries, third world countries, every 500 hours. It is highly recommended to change oil every 250 hours. So this filter will be replaced every 250 hours. You know, by experience, we are not encountering any issues with these filters, you know, getting clogged early or something, unless you have an issue with the fuel that you are using, dirty fuel, for example. Other question? How to reach the airlock in 4012 engine? Oh, this is the old version of engines, which used to have air dampers. We called it air dampers. Okay, first, you need to reset the fault. On the very old engines, they used to have a relay box, white relay box mounted on the alternator side, AC alternator side. It has a push button. You need to press on the push button to reset the fault on the controller, the Heisman controller or the ProAct controller, and go up at the top where the air filters are, where the dampers are locked. You need to open these manually. That's how we do it. Another question. Good day. Is it normal for 4006 engine series to consume oil when the generator set is under load? If so, how can we rectify this? Yes, this is an issue, if you want to call it an issue, with these 4000 series. They consume a lot of oils, especially at commissioning, you know, when the engine is still brand new. If you run these engines with a load below 40%, there's a great chance they will consume oil. What we recommend is to have a minimum load of 50% or even more. If you're going to 70 or 80% load for the first 1000 running hours, this will be great. The remedy for cutting down on the oil consumption is to use or apply high loads on these engines. That's how we rectify this issue. Another question. What causes 1000 kVA 4008 THG2 to get its turbo and exhaust manifold becoming red with 60% load? What causes redness on exhaust manifolds? We see this all the time. High loads, which does not apply in this case, clogged air filters, leakage from the air cooling system from the radiator side, or if the injectors are spraying, you know, extra fuel. They must be, readjusted, calibration timing process, or they might be defective. They will be spraying too much fuel. Okay, whenever you have too much fuel sprayed, you will be seeing this glowing red. Okay, another question. How to reach airlock in 4012? We already answered this question. Okay, when the load is less than 25% of engine load, is the active side of the engine will be the same or the running time will be divided between the two engine sides? That's a good question. Whenever you run the engine with load below 25%, bank A will be running. If you shut down the engine and you start the engine again, but still we have a low load, it will be bank B instead of bank A. And a good advice, if for some reason you have this issue and your engine is running with either bank A or bank B for some time, it is highly recommended after some time to run the engine at high loads, like 80% load for many hours, 4 to 5 hours, to get rid of the carbon deposits that will be accumulated inside the combustion chambers of the engines. Okay? Another question. How can we rectify if 4008 starts but does not carry load up to 50% and the injectors are okay? There must be something wrong in here. Usually, you need to go for a fault finding. Check the fuel filter, you know. Check the fuel filters first. You know, this is fault finding. Start with the easy things. Because if the engine is not taking load, it means there is something wrong. There is a fault. I'll go with the easy steps first. Check the fuel system. Start with the fuel filter. Do we have a fuel in the tank? Is the fuel dirty or it's okay? Are the injectors okay? You need to take out the injectors and check them with the special tool that I have showed you. Okay? Uh, if the engine has run for so many hours, you don't have enough compression in the engine, or if big loads are applied on the engine, impact loads are applied on the engine, it might not take, the load. So you need to go step by step. I will start with the easy steps. Other questions? How to cut Pandar's governor software for Perkins 4008 THG. You don't have to, because these controllers, whenever we buy them, they are already programmed. Okay, the program is there. No need to reflash the controller. Another question. Okay, so this is it for today. Thank you guys. Thank you everybody for attending this training, and hopefully sometime in the future we will be talking about session 2, calibration and timing for injectors. Thank you very much.